This is video number 5 in our series on considering various topics in Fourier analysis. A reminder that the playlist for all the videos, the playlist will be featured at the website digital-university.org. What we want to do in this video is work with this expression, which we presented in the first video, and use this to develop a complex expansion formula for a Fourier expansion type problem. And remember now that what these Fourier coefficients are. A sub n is this. So notice that a sub n would be equal to a minus n. So put minus n in here. The cosine is an even function, so it comes out to be the same. So a n and a minus n are equal. Here, for the b, if we put minus n here, well, the sine is an odd function. The sine of a minus angle would be minus the sine of that angle. So b sub n will be minus b of minus n. And we'll make use of these in just a few moments, these two relationships. Also, remember that we have these relationships. E to the I theta is this. E to the minus I theta, again, if we put minus theta in here, that's the same as the cosine of theta, because the cosine is an even function. If we put minus theta in here, then that's the same thing as minus the sine of theta, because the sine is an odd function. Now, if we add these two, these cancel, so we will have that the cosine of theta is equal to the addition of these divided by 2. And if we subtract these, then these cancel out, and we have that the sine of theta is equal to the difference of these divided by 2 times I. And we're going to make use of these formulas in just a few moments. So let's start with here, where a sub n times the cosine of n omega t, that would be the same thing as then 1/2 a sub n times e to the I n omega t plus e to the minus I n omega t. And for b sub n times this, then that would be the same thing as 1 over 2i times b sub n times e to the I n omega t minus e to the minus I n omega t. So let's rewrite the formula for f of t, inserting this in here and inserting this in here. What would that give us? Then we would have f of t will equal a naught plus this sum, where here we have 1/2 a n times e to the I n omega t plus e to the minus I n omega t. Then we have, now here we have plus b sub n divided by 2i. If you want, we can take the I upstairs. 1 over I equals minus I, because I squared is -1 times -1 becomes +1. So this would be minus I over 2 b sub n times e to the in omega t minus e to the minus in omega t. And of course this is all sum from n equal 1 to infinity. Now let's look at this. Here we have e to the in omega t, and here we have e to the plus I n omega t. And here we have e to the minus I, e to the minus I. So let's write it like this. F of t that equals a sub 0 plus our sum here. And now we're going to have e to the in omega t, and what do we have? We have an over 2 minus I bn over 2. So that would be times an minus I bn divided by 2. Then we have e to the minus I omega t, and here we have 1/2 an, and then over here we have plus IBN over 2. So this will be a sub n plus I b sub n divided by 2. This isn't written very neatly. This is a sub n plus I b sub n. So that's our expression so far for f of t. Of course, this is summed from n equal 1 to infinity. Now, notice that this and this are complex conjugates of each other. And this is one constant minus another constant divided by 2. So let's call this Cn. Then this would be Cn complex conjugate. But there's something more to consider here. Let's just write it down here. Cn is this. What is C of minus n? Well, we said before that A of minus n is an. So this would be an. Then we have minus. But B of minus n, that's minus bn. So this is going to be plus I bn. Remember that B of n equals minus B of n. So we'd have minus comes out to be a plus divided by 2. So this here we could write as the complex conjugate of Cn, or we could designate it as C minus n. Either way is legitimate. And we're going to use this expression. So this is C of minus n. Now, what do we have? We have f of t equals a0. Actually, let's make some more room. F of t equals a0 plus the sum n equal 1 to infinity, and then we have c sub n e to the I n omega t, and then we also have plus c minus n times e to the minus I n omega t. Now, what we can do, instead of having a0, since these are defined in the c's, then let's just call this c0. Now, what happens in this expression if n, we're summing from n equal 1 to infinity, what happens if n is 0? This is 1, we have c0 times 1, that gives us c0. So in fact, we can just take this away and sum from n equal 0 to infinity. Now, let's take a look at this some more. And actually, before we do that, let's go back. We had c0, and we were summing over both of these from n equal 1 to infinity. But let's split this up. Let's say we have this sum plus we're going to have, and write this as a separate sum. So we're going to have plus the sum n equal 1 to infinity, and we have c minus n e to the minus I n omega t. Now, let's go ahead and incorporate this into here like we just did a moment ago. So this will be sum from n equals 0 to infinity. Now, let's take a closer look at this part of the formula. What we have is we're summing over from n equal 1 to infinity, negative n here and negative n here. So instead of doing it like that, we could just say, well, let's take the sum from minus infinity to 1 and have these as positive n's. Like this. Then this would give us nothing but the negative n's that we had up here before. Actually, we're going from minus infinity to minus 1. So all these n's that we're summing over will be negative n's, just like they were right here. So in place of this, we can now insert this. So let's erase this. We have plus the sum, n goes from minus infinity to minus 1 of c sub n e to the I n omega t. And we don't need this down here any longer. Okay, so we have two summations. Both involve c sub n e to the I n omega t. This goes starting at n equals 0. Well, this one goes from minus infinity to minus 1. then this picks up going from 0 to infinity. So we can combine these into a single expression like this. F of t will equal the sum n equal minus infinity to n equal plus infinity c sub n e to the I n omega t. And that is the Fourier expansion when we're using the exponential form. Now what we haven't shown yet is how do you determine what c sub n is. And we're not going to have time to do that in this video. We will do that in the next video. How we determine c sub n, and then we'll put the two formulas together. Another thing that we want to point out is sometimes you'll see it written where you have this equals C0 is out here. We can just make some room to show that. Sometimes you'll see it like this. F of t equals C0 plus the sum n equals minus infinity to infinity, n does not equal 0. And then we have Cn E I n omega t. Okay, that's all we have time for in this video. Come back, join us in the next video. We'll determine how to figure out c sub n, and then we'll put our two formulas together. So come back, join us for the next video. We'll try to pick off where we left off at this point.